Okay, can you hear me? मेरी आवाज आ रही है?
Yes sir.
ओके, तो कैमरा से भी ऑन करो जल्दी। इसके कमी है 1 2 3 4 5 6। उमर तुम अभी जागे?
सर
हाँ
नहीं सर।
अच्छा, लग तो वही रहा है।
एक्चुअली सर यहाँ पे गार्डन चल रहा था रात से, तो इसलिए जाग ही रहे थे।
अच्छा, तुम शुपिया में हो?
यस सर।
फिर से गार्डन? अरे यार, क्या करें, हमारी तो लाइफ इसी में गुजर गई हो। मेरा एक दोस्त था, उसकी दुबई में जॉब, इंजीनियर है, तो अब वही काफी साल हो गए उसको। उसने बोला जब मैं पहले दिन वहां गया ना, उसने पता है पहला काम क्या किया? उसने बोला मैं रात भर दुबई की सड़कों पे घूमता रहा, क्योंकि मैं कभी रात में घूमा नहीं था सड़क पे। यहाँ हर तरफ कुछ ना कुछ होता था। उसने बोला पूरी रात में बस दुबई की सड़कों पे बैठा रहा रिलैक्स करने के लिए। ठीक है, ओके, सभी कैमरा ऑन कर लो, शुरू करेंगे फिर। कल हमने लास्ट वाला क्या किया था? हमने वो फिनिश किया था a प्लस बी इंटू ए इज इक्वल टू ए प्लस बी ए फॉर पॉजिटिव नंबर्स इफ एंड ओनली इफ। ये पूरा हो गया था कि इससे आगे भी हमने कुछ किया था? एनीबडी रिमेम्बर? यानी हमने ये प्रूव किया था पूरा कि a प्लस बी टाइम्स a इज इक्वल टू a plus b into a. A is a subset of a vector space.
सर ये हमने किया था।
पूरा किया था?
सर फिर हमने लिखा था z इक्वल टू a अपॉन a प्लस बी इंटू यू प्लस b अपॉन a प्लस बी इंटू वी।
यानी हमने वन साइड किया था, मुझे भी वही लगता है। हमने दिखाया था, अगर हमने लिखा था if a is convex then it is true.
यस सर।
हमने किया था if a is convex then a plus b into a is the same as a plus b plus b into a for all a b greater than equal to 0. शायद यही किया था। अब इसका कन्वर्स शायद हमने नहीं किया था। Conversely, suppose that this is true and we will show that a is convex. Conversely, suppose that a plus b into a is the same set as a into a plus b into a for all non-negative a b's. हम दिखाएंगे ये कॉन्वेक्स है, सो वो बिल्कुल इजी है, बिकॉज लेट एक्स वाई belong to a and let alpha be a number between 0 and 1, and putting a equal to alpha and b equal to 1 minus alpha, of course both are non-negative. तो अगर हम ऊपर वाला इसको अप्लाई करें, it implies that alpha x plus 1 minus alpha into y जो है, it is like a, बिल्कुल सही, it belongs to a plus चलो मैं ऐसे लिखता हूँ, अगर मैं इसको मानता हूँ बाय माय एजम्पशन, it belongs to alpha a plus 1 minus alpha times a, which is the same thing as alpha plus 1 minus alpha times a, which is the same as a. So therefore a is convex. ये हो गया अपना कॉन्वेक्सिटी का एक क्राइटेरिया। देन इसी के साथ हमें कुछ और, हाँ ये एक और थ्योरम हम कर सकते हैं, ये है कि फॉर एनी कॉन्वेक्स सेट C and alpha positive but less than equal to 1, alpha C admit interior minus 1 plus 1 minus alpha times closure of C is contained in interior of C. ये तो इसका 1 होगा। दूसरा इसी में से हमें मिलेगा if C0 interior is not equal to 5, then पहला तो C0 का closure is contained in C is equal to C, contained तो होगा ही, is equal to C closure, and C closure का interior is equal to C interior. So that was the point. Okay, now proof. Now obviously if alpha पहले हम 1 करेंगे, ठीक है, if alpha is equal to 1 there is nothing to prove. क्योंकि अगर alpha 1 है, it would simply mean C closure is C interior. You know what is C interior? चलो मैं लिख देता हूँ, C interior by definition is the largest open set contained in C. And C bar, C closure, is the smallest closed set containing C. And that's the definition. Okay, agar alpha 1 has, so we may assume alpha is less than 1. So let 0 be less than alpha be less than 1. And let x belong to C0 and y belong to C closure. Okay, so then we can choose, because if something belongs to the interior, it means that it is contained in an open set. So open set ka matlab you can find a radius, you can find at each point you can find a ball that is contained wholly within that set. It implies that we can choose R positive such that Brx is contained within C0. That's the definition of an open set, and of course C0 is an open set. Okay, so just a minute, मैंने क्या किया? Brx is contained in C0, that's fine. And which is of course contained in C, because C0 is the largest open set contained in C. The interior of C is contained in C. Also, since alpha divided by 1 minus alpha multiplied by this Bry is a neighborhood of y belonging to C closure, it must intersect C, because that is the definition of closure. Every every point inside C closure, it has every neighborhood of that point intersects C. So therefore it must intersect C. यानी हमें कोई मिलना चाहिए Z. Therefore there exists some Z which belongs to, of course, C, and it also must belong to alpha divided by 1 minus alpha into B R Y. Okay, then, and implies that norm of y minus z is less than alpha divided by 1 minus alpha into R. That is just the definition. If z belongs here in this set, then this must be true, which implies that 1 minus alpha into y minus z must belong to alpha times B R at 0. Just a straightforward verification, which is my. Now, since C is convex, V अगर मैं लेता हूँ set of alpha times BRX plus 1 minus alpha times Z is a subset of C, because BRX जो है, it is contained inside C. Z also belongs to C because it belongs to C as well as this open ball. तो इसका मतलब any convex combination of this type must belong to C for any alpha lying between 0 and 1. So, but alpha x plus 1 minus alpha times y can be written as alpha x plus 1 minus alpha into y minus z plus 1 minus alpha into z. So I can write it like this. As you can see, 1 minus alpha times z would cancel out. So this would belong to alpha x plus alpha into BR at 0 because of this, let's call it star, plus 1 minus alpha times z. It is set by star. But this is the same thing as when I multiply this and take alpha out. This is the same set as alpha times BR at x. BR at x matlab, the ball, open ball centered at x with radius r plus 1 minus alpha times z. So this is okay, but this is an open set. So you have got alpha x plus 1 minus alpha times y belongs to this alpha BRX plus 1 minus alpha times z. Now this is an open subset of C. The reason being, now subset to hai because it is C is convex and BRX is contained and Z is also contained in this. So पहले तो ये है कि जो मैं ऊपर देखो BRX जो है that is contained inside C, right? And all x's there are inside C, and of course Z also belongs to C, as we can see. That means this set is actually indeed a subset of C. अब ये है open subset है because C is convex. ठीक है? अब is it an open subset of C? Now look at this. Okay, it's an open subset of C because right, this is an open subset of C because translation would send open set to open sets, right? Because पहले तो ये है कि it's a subset of C. The question is it open? है ना? C is convex, therefore alpha BRX clearly plus 1 minus alpha times z. This belongs to, now this is contained inside C. The question is it open? Open इस वजह से है because BRX is open and scalar multiplication plus the vector addition, they are homeomorphisms. So they would send open sets to open sets. So if BRX is open, any scalar times that plus some vector would again be open. Subset to hai hi, therefore it's an open subset of C. And therefore it implies that alpha x plus 1 minus alpha times y must also belong to C interior, right? Because this is the largest open subset of C. तो ये largest है, तो ये भी open है, तो therefore this must be a subset of C. So therefore any open subset of C must be a subset of the interior. Therefore it must belong to C interior. So which implies that जो कि हमें चाहिए था, because C naught x हमने लिया था, C naught में ये लिया था कोई भी arbitrary element of C closure, तो we get alpha C naught plus 1 minus alpha times y. I'm sorry, C closure is a subset of C interior. So that was first. The second one is, now this is true for all alpha lying between 0 and 1. So letting alpha approach, yeah, putting alpha equal to 1 by n, that would do. And letting it approach, what we call, letting alpha approach 0, we get, so let's go second round. Second round, second first part. If we let alpha approach 0, I should get alpha C naught plus 1 minus alpha को अगर 0 approach करेंगे तो ये खत्म हो जाएगा. So you would get basically C closure is contained in C interior closure, right? Provided that C interior is not equal to 5. That's already given. Part second में, है ना? Part second में तो हमें दिखाना है C closure, C interior closure is equal to C closure. By first letting alpha approach infinity, because then actually you can take alpha equal to 1 by n, letting n approach infinity rather than alpha approach 0. बात एक ही है. You would get C closure is contained in C interior का closure, but this is always true. C interior is always contained in C, which implies that C interior closure is always contained in C closure. Because if A is a subset of B, then A closure would be a subset of B closure, which implies that C closure should be the same thing as C interior closure, provided that it's not equal to 5. क्योंकि अगर ये 5 है interior, तो उसका मतलब ये नहीं है कि C भी 5 होगा. तो फिर of course this is not true. ये तो हो गया पहला. अब दूसरे में थोड़ा सा हमें काम करना होगा. But we also want to show C closure का interior is equal to C interior. ये उसका second part है 2 का. उसके लिए थोड़ा सा हमें करना पड़ेगा कुछ. So let now fix, now for second part, fix some x naught belonging to C naught, that's the interior of C, and x belonging to C closure का interior, right? यहाँ पे x लिया, तो यहाँ पे x naught लिया. Now since x belongs to C closure का interior, so now there would exist, now we choose R positive such that BRX जो है, it is contained in C closure. So that's the definition of the interior. Now choosing epsilon equal to positive, choosing epsilon positive with 0 less than, with epsilon less than 1. Yeah, choosing this ऐसे directly. We choose a positive number that is less than 1. We can find yeah, ऐसे लिख सकते हैं, with norm of x minus x naught strictly less than r by epsilon. We can do that because x naught belongs to the interior and x belongs to the closure का interior. यानी x naught जो है वो belong करता है C interior में, which is contained inside C, and x जो है वो belong करता है C closure का interior, जो कि हम दिखा चुके हैं बराबर है, of course, which would be contained inside C closure. So x belongs to C closure, x naught belongs to C. That means they are arbitrarily close, and for any epsilon we can, there must exist some number such that the distance between x and x naught is less than this r by epsilon. We can find such an epsilon, right? Because it has to be arbitrarily small, so I can choose epsilon between 0 and 1 so that this can be made appropriately small for this particular x naught and this x belonging to C closure. ठीक है? तो once I am done, तो ये अगर हमने किया तो हमारा आधा कम हो गया, because this implies basically epsilon into x minus x naught must belong to BR0. यानी its length should be less than R. That's obvious by this. Which implies that x plus epsilon times x minus x naught जो है वो belong करेगा BRX में, which is contained inside C closure. So therefore by 1 जो हमने पहला वाला inequality की थी, x minus epsilon into x minus x naught plus something in the interior. Now you can write it as epsilon times x naught plus 1 minus epsilon times x. This must belong to C interior. That's our first, because first क्या है? First ये कहता है alpha times C naught plus 1 minus alpha times C closure is contained in C interior for all alpha lying between 0 and 1. यहाँ पे alpha की जगह epsilon है. So, but अब अगर ये C naught में है, तो by another application of 1, मतलब मैं फिर से इसी का another application of 1, I would get, we get 1 by 2 into x minus epsilon into x minus x naught plus 1 by 2, मैंने अल्फा की जगह 1 by 2 लिया, x plus epsilon into x minus x naught. This must belong to C naught. वही है अल्फा times that, मतलब जो ना यहाँ पे था, हमने यहाँ पे किया, ये एक वेक्टर लिया, दूसरा लिया x, दूसरा लिया ये एक वेक्टर और ये दूसरा वेक्टर, यानी इनका जो कॉन्वेक्स कॉम्बिनेशन है वो C इंटीरियर में होना चाहिए, और वो पर्टिकुलर कॉम्बिनेशन मतलब फॉर ऑल अल्फा दिस शुड बी मतलब सम अल्फा टाइम्स दिस थिंग प्लस 1 माइनस अल्फा टाइम्स दिस वेक्टर should be inside C interior. तो we chose our alpha to be 1 by 2. लेकिन अगर हम देखें, this is just ये और ये खत्म हो गए, this is just x. So it would imply that हमने x किया था शुरू C closure of interior. So it implies that C closure का जो interior है, it is contained inside C interior. But C closure का interior is contained. But we know that, okay, अब देखो C closure का interior is contained in, ये हमारा proof हो गया, but C interior जो है, it is contained in C, which is contained in C closure, right? So what? So this is an open set contained in C closure. तो हमें दिखाना ये बराबर है, हमें बेसिकली इसका रिवर्स दिखाना है ना. So I have got so far, जरा मैं इसको ड्रॉप करता हूँ यहाँ पे, ये हम प्रूव कर चुके हैं। ओके, सो लेट मी गो टू बैक पेज. What do I have to show? I have to show that C closure interior is equal to C interior. C closure interior is equal to C interior. अब हमें पता है कि C interior is contained in C, which is contained in C closure. हाँ ठीक है, but C interior is always contained in C, which is contained in C closure, and C interior is an open set. Therefore, C interior is contained in C closure interior always, and hence combining the both, combining this, let's call it star and पता नहीं जो भी नाम है, तो I would get C interior is the same as C closure का interior. थोड़ा सा लंबा चौड़ा, but that's what it is. था simple सा जो हमें प्रूव करना था, but this is important कि अगर C interior phi नहीं है, then C interior is the same as C closure का interior provided C is convex. Okay. तो ये करने के बाद we want to go to Kreil-Milman theorem. Because before that, let me give you an home assignment. If T from X to Y be a linear map, of course, where X and Y are vector spaces, let K be a convex subset of Y, show that if E is an extreme subset of K, then T inverse of E is an extreme subset. You have to use basically the definition, extreme subset of T inverse of K. और of course तुम ये भी प्रूव कर सकते हो, जो कि बहुत ही easy है. चलो इसको first मानते हैं, इसको second. That intersection of convex sets, no, howsoever many, intersection of convex sets is convex. Now let's come to an important result, which like Hahn-Banach theorem looks like, मतलब अगर हम usual vector spaces या जो हमें concrete spaces हैं से जिनको हम as a prototype use करते हैं, से R2, R3 जहाँ पर हम चीजों को verify करते हैं ज्यादातर, तो उनमें तो ये obvious सा result लगता है, लेकिन we are supposed to generalize it for most general, no, any sort of normal linear space. So that is our Krein-Milman theorem. The statement लगता है for R2, R3 straightforward, लेकिन for a general abstract normal linear space, it requires a proof, and that requires Zorn's lemma. So let me write it down, Krein-Milman theorem. Krein-Milman theorem says let K be a non-empty compact convex subset of a normed linear space X then of course two things. पहला, A, K has an extreme point. इसका हमेशा एक extreme point होगा. K has an extreme point. अगर एक compact है और convex है. that is epsilon k, the set of all extreme points of k is not equal to phi. B है k is the closure of the convex hull of its extreme points. By that I mean k is equal to conv of epsilon k. Conv का मतलब convex hull, उसका closure. So that's what we have to show. Now अगर मैं तुम्हें कहूँ R2 या R3 में, ये तो कुछ है ही नहीं, ये तो obvious है. You take any compact set, it would be some closed, मतलब a convex set that's closed and bounded, right? यानी compact है. अगर तुम्हें लोगे तो obviously इसमें extreme point तो है ही, बहुत सारे हैं. और अगर ये polygon है, उसमें भी है finite set. तो ये सारा का सारा जो है extreme points तो होंगे ही इसके. Furthermore, अगर मैं इन extreme points का convex हल लेता हूँ, यानी smallest convex cell which converts it, it should be exactly equal to the set itself. या इनका convex हल जब मैं लूँगा extreme points का, we get the set back. So that's straightforward. That seems an obvious statement, but we are talking about an abstract, any normal linear space. So where need not be R2, R3, it could be a collection of functions. It could be bounded sequences, it could be convergent sequences, it could be continuous functions, it could be Lebesgue integrable functions. No, it would apply to all. Right? We don't have points like this where we have points instead of points. You would have functions and you would have different ways of assigning them length or assigning the distance between two vectors. It could be in terms of integral, in terms of supremum of the, बहुत सारे तरीके हो सकते हैं. तो उन सब के लिए it would encompass all those huge, diverse, normal linear spaces, but this would apply to all of them. So anyway, proof मैंने जैसे कहा, इसमें हम use करेंगे axiom of choice or Zorno's lemma. So we start with consider the family of sets F such that F is a subset of K, where K is our non-empty compact convex set, and F is itself a non-empty closed extreme subset of K. So then पहली बात तो ये है, this is not equal to phi. Why? Because K itself belongs to this set, because K is a subset of K. K is non-empty. It is compact, therefore it is closed because we are inside a, मतलब क्या बोलते हैं, Hausdorff space. So it's non-empty, closed, and it's an extreme subset of itself. Obviously, K is an extreme subset of itself because none of the vectors in K can be written as a convex combination outside K. So every convex set is an extreme subset of itself. That's trivial. क्योंकि अगर ये है convex set, तो कोई भी element जो यहाँ पे होगा, it cannot be a convex combination of elements outside it. क्योंकि by definition, all convex combinations lie within K. So okay, so it's not phi. पहला set. Now we introduce a partial ordering. Introduce a partial ordering on this by set inclusion. That's ऐसे हम बहुत बार कर चुके हैं अब तक. Set inclusion मतलब मैं इसको एक partially ordered set बना सकता हूँ जो भी f इसमें है, यानी f1, f2 जो भी इसमें होंगे, मैं कह सकता हूँ f1 is less than equal to f2 if and only if f1 is a subset of f2. because this is collection of sets, so this set inclusion would define a partial order on any collection of sets. Basically, in particular this one, we show that every chain, every linearly ordered set, every chain in this set has a lower bound. लोअर बाउंड की मैं बात कर रहा हूँ, इससे पहले हमने वो अपर बाउंड किया था, बट इक्वली गुड दिस इज आल्सो अनदर वर्जन ऑफ सॉल्वेंट्स लेमा. तो अगर मैंने वो दिखा दिया कि एवरी चेन इन एफ हैज अ लोअर बाउंड, इट मींस देन दिस मस्ट हैव अ मिनिमल एलिमेंट. सो लेट्स कंसीडर अ चेन. So let this E sub I belonging to delta be a chain inside K, and E equal to intersection of all I belonging to delta EI is clearly a lower bound of this chain. Lower bound of this chain. Why? Because of course E is less than equal to EI, which means इसका actually मतलब है कि E is a subset of EI for all I. Because intersection है तो ये इसका lower bound है. तो every chain, the question is, does it belong to K? है ना? So intersection of extreme subsets would again be an extreme subset. You can check that, right? Of course, it is non-empty because it's a chain, है ना? So पहले तो ये chain है. Chain का मतलब क्या होता है? You would have a situation like even मतलब it goes like this. It will go both ways. It need not start from somewhere. तो जो intersection होगा वो सबसे छोटा वाला सेट होगा. वो obviously extreme subset है क्योंकि ये सारे के सारे extreme subset है. So E is an extreme subset. Of course, क्योंकि सारे के सारे subset of K हैं तो ये भी subset of K है. यानी ये जो इधर ये criteria है इस F में होने का वो सारे satisfy करेगा because just because it's a chain. So lower bound of this chain. So अब एक ही चीज है जो दिखाने की जरूरत है कि E is non-empty. तो we show that बाकी सारी प्रॉपर्टीज तो ये टिक करेगा ही, non-empty का देख. We have to show that क्योंकि ऐसा हो सकता है कि you have got an infinite subsets, collection of subsets, लेकिन जब उनका intersection हो वो phi हो. हालांकि वो phi नहीं है लेकिन उनमें कोई भी एलिमेंट कॉमन नहीं हो जो सारे के सारे सेट्स में हो सकता है. 2, 10, 50 में कॉमन हो लेकिन सारे के सारे में कॉमन हो ये जरूरी नहीं है. तो we show that, we have to show that E is non-empty. Now EI जो है, because it lies inside this set, it's a collection of closed sets. That's important. अब चूंकि ये सारे के सारे closed हैं, arbitrary intersection of closed sets is closed. तो ये जो collection of closed sets है, so it's a closed set. So it's a collection of closed sets by being inside K. It has to be a collection of closed sets of a compact subset K. Now that's important. Of a compact subset K, therefore, with finite intersection property. ये खत्म होने वाला है इसलिए मुझे लगता है ये important part है. मैं इसको बंद करता हूँ, तुम फिर से ज्वाइन करो. हेलो, कि तुम सो रहे हो? मैं इसको एंड कर रहा हूँ, तुम रीजॉइन करो.